Thank you for the short introduction. I'm happy to present a just upcoming and starting project within the EBC, and it's a joint project, so it's a special project that runs under two technology collaboration programs. So it also runs in cities, in the cities TCP under Task 5. Short introduction of myself and my colleague, we are like the operating agents of this new project. We are from the Institute of Building Research, as already mentioned. We are based in Vienna. These are our main focuses. So we work on sustainable and zero carbon heating and cooling. And as in many cities, there's a huge building stock, so we're really looking at decarbonizing the building stock. And I myself, I work a lot on climate adaptation and of the built environment. So as temperatures are rising, especially in countries that have not experienced such heat waves and hot weather before, I'm looking on how we can adapt and still maintain livable cities. So the Sustainable Cooling in Cities project arose from a previous project that was more focused on buildings, resilient cooling of buildings. And what we learned there is that, of course, climate change hits the world, and that there are a lot of challenges for the built environment to maintain the quality of life and to reduce, but still reducing energy consumption and CO2 emissions. So cities are particularly affected by this. So what we see is that the challenges, but also that the chances that they accumulate in cities. And as more and more people live in cities, it is really important, of course, to increase the energy efficiency while securing the resilient cooling of buildings. And this is strongly interconnected to the heat mitigation in cities, so the surrounding of buildings, as buildings make up a city. The focus of this particular project is, as I mentioned already, the health and well-being in cities. So by cooling and despite cooling. Cooling is, as mentioned in the last World Energy Report of the IEA, one of the driving factors for energy consumption in the near future, especially in countries with thriving economic growth. And so we address these three UN Sustainable Development Goals mainly. So this is good health and well-being, climate action, and sustainable cities and communities. The general objective of this project is, of course, to increase and spread the knowledge. This is in many projects you've seen before in the IEA and in the technology collaboration programs. It's about sharing the knowledge, learning from each other, and spreading the new knowledge. So we are looking about solutions for urban heat mitigation and sustainable cooling of the buildings and their immediate surroundings. As I mentioned before, we are right at the beginning of the working phase. So we had a 1-year preparation phase to write the project description and the work plan, which I will go into detail a bit later. And we have 4 years ahead, 3 years working on the project, on the activities, with several meetings they already laid out, and then a 1-year reporting phase to write up the project reports. So as for structure and topics, briefly, we're looking about urban settlements, so we're excluding rural areas. We work on all climate zones, so I know that there's a bias in the EBC and IEA, which we have a lot of teams from Europe and the US, so more like temperate climate zones, but we really want to look in all climate zones. And I think we can learn from climates that are already hot nowadays. But the projections say that Vienna is becoming like Istanbul, you know, and I think this is why we can really learn from each other. As I mentioned already, we deal with meshes in the building, but also in the surroundings. We are looking at 4 different categories of solutions. So that these are nature-based solutions, mechanical solutions, gray solutions. We had a discussion earlier, what is a gray solution, what is a but anyway, so that there's gray solutions like structural shading, for instance, but also soft solutions. We call them soft solutions, and this is more on a management base. So this is like behavioral changes, or let's say recommendations for people to cope with the heat, and of course political measures. So as before, the project structure is mainly focusing on these 4 tasks, subtasks. So the subtask fundamentals is about the creation of the basis for the upcoming research. So this is looking into standardization and creating some kind of an overview what is already there, and which comfort models exist also for the authors. Methods is about simulation tools and experimental methods. So how can we evaluate the solutions that are already there and advance them? So this is then feeding into the solutions part, where we look at these 4 categories of solutions. And then, of course, finally, already during the course of the project, how can we translate the findings into action? And this is usually through policy to make it really happen, that that things can change and advance. I will briefly go into these objectives of these subtasks, and then show some examples that has been already dealt with. So in this subtask, as already, we develop a sound knowledge base of comfort targets and health requirements for performance indication of the effectiveness of solutions. The audience here is more science to science, so this is maybe more interesting for you. And of course, we target health and HVAC organizations, and the impact that is really important here is that we have an improved knowledge, and we can improve the assessment of heat mitigation strategies. So there are four activities, and as you see, they are mainly targeted towards researchers, but also in the planning. I won't go into detail here, but if you think that in some of these activities you want to know more, then just give me hands up and I can answer your questions. So about the methods, this is really about building research, so it's like simulations and experimental methods. So it seems that there's a widespread set of tools that is already available, but it lacks of, let's say, harmonization of different methods and experiments. So that this is also science to science, but also science to practice, as these tools are used widely by planners and consultants. And the impact here is that we want to enable accurate planning, because of course a building is standing for decades, but everything that is laid out in the planning phase will then affect the later life of the building. So this is really important here, and of course then the surroundings of the building as well. Several more activities here, but as you see, it's again more science to science, and I will go into one specific activity here, and this is the review and the evaluation of experimental methods. And my colleagues from Perugia University, they have an ongoing project, the Helios project, which is on passive daytime radiative cooling materials. So these materials, I don't know if you're familiar with radiative cooling materials, but they are believed to be a scalable heat mitigation solution. As you can see on the graphic here, depending on the outdoor temperature, they can change their emissivity. So this is adaptive photoluminescent radiative emissivity of the skin of a building. So when the temperature rises, the emissivity within the atmospheric window, which you can see here. So this is a normal spectrum with the wavelength on the y-axis and the emissivity on the y-axis and the wavelength on the x-axis, and the atmospheric window is somewhere around here, which allows infrared radiation to escape out of the atmosphere of the planet. And when the temperature changes, this emissivity, as you can see here in the red, changes too. So when it is cold, these skins don't radiate the heat, but when it gets hot, they open up in this atmospheric window, and they can, radiate the heat out of the atmosphere. And this is directly related to this activity: review and evaluate the experimental methods. So they are building a climatic chamber and solar simulator where they can put sheets with this coating, and then simulate the atmospheric window and really prove and simulate the heat exchange through the atmospheric window. And this is something very promising, as it can be applied on a huge scale on roofs in buildings in the city. And this leads directly to the solutions. So, as mentioned before, we are reviewing and comparing what is already there, solutions for heat mitigation and sustainable cooling solutions in cities. And this is targeted more towards industry, because they are advancing these solutions, but also the application then of these solutions through planners and architects or HVAC designers. And we believe that this can increase the energy and carbon efficiency of urban cooling, and as a consequence, increase the livability in the built environment. Again, 5 activities happening here, but they are mostly addressed to policymakers, urban planners, and consultants. I want to show one of, so this is the list of cooling solutions we were looking at, and in the preparation phase, they are grouped in these 4 groups, as I mentioned already, and I will just go in and show one solution that in an assessment we did before has not been rated very well developed, and so we got into this for a report, and this is water sprays and misting. So this is how we put it in the state-of-the-art report that has been coming out of the preparation phase. So you see, this is a widespread, in some cities already applied solution where water is through high pressure pressed through nozzles to mist the surrounding and therefore cool the spaces. So it uses treated drinking water, which is not available in all places of the world, but this is a very important prerequisite, as the aerosols, they can also be inhaled, and this is very important that this is clean water. So, and through this very small diameters of the nozzles, they get a very atomized mist. As you know, you see some nozzles of them here. So you need very high pressure for some procedures, and of course you need to control the pumps that provide this pressure and the flow rate of the water. So this is some more detail, and you can, they are sometimes on poles, but sometimes also on the ground. And in the state-of-the-art report, we have like a colleague that works on this and laid out what kind of mist regimes you can accept from these nozzles. And this is just to show also that it's very easily applied to the practical theme, because you see here in 1 to 0 meters from the nozzle itself, users should not be exposed, because this is a very, let's say, very wet milieu, and people would, you need to expect that they get wet. People might already like it, like a half a meter or 2 meters away from the nozzle. But this 2 meters to 10 meters is where the cooling of the air really happens. So this is just an example of how we look at the solutions and what knowledge we gather and then make available to, let's say, planners or architects. Some rough performance estimations that also can help to promote such technologies, especially when you need to convince somebody, like the city authorities, to implement such measures. You see that in, let's say, temperate climates, you can reach up to, theoretically, a temperature decrease of 10 Kelvin. But in practice, this is at a relative humidity of 100%, but in practice, it's half to 1/3 of this. So, and another activity that is happening in this group of subtasks is that we want to establish a community of practice and exchange. So this is also what I mentioned at the beginning. The annex is really about gathering the existing knowledge and spreading and learning from each other. So within this project, we have an advisory board of practitioners and industrial partners. So this is also very important to connect the researcher with the industry, and to get some feedback and see what are they improving and working on at the moment. And in parallel, we have a Sustainable Cooling in Cities lecture series. So this is, again, fostering the exchange and the discussion between the researchers. So these are very low-profile presentations where people just talk about what they're working at the moment, and then you can have a discussion with people around the world, and and you get the mind going and then spin ideas. And this is starting in spring 2026, and we're excited that this has been already in the previous project a very lively platform for discussion and exchange of knowledge. And finally, this task is about how we then have the knowledge from reviewing and analyzing the solutions, how we can get this into action, and this is through policies, of course. And so here we look at existing policies. We talked with the city networks, and we encourage the applications of these solutions. What should come out is some kind of a policy guidance, so small, short, concise policy sheets that can be handed to policymakers and help them see, okay, well, in this country this worked very well. Maybe it is something that could also work in your community. So this is science to policy making. So this is a completely different way of communicating the results, and but this is at the end empowering and encouraging to implement these measures, as I showed, maybe the misting at some point. And finally, of course, this can support the social cohesion in a city, because when we have livable outdoor spaces where people meet and stay for longer than just walking through, this can really help to improve the social life in cities as well. There are 3 activities, but as I said, they're mainly focusing on policy makers. So the review of the existing policies, which is very interesting, that learn from different countries what is been implemented there, how is it working, and maybe transfer it to other countries. So to conclude this, so what is the project, who is participating, and what are the opportunities here? So I just a list of already interested in participating countries and research groups. Maybe if you go quickly through, you see that there is some lack of countries from the global south. So this is really something we really want to work on, to learn from these countries as well. As I mentioned at the beginning, this is where the economic growth is happening, and this is where the transformation from non-cooling, or let's say not so intense cooling of buildings and outer spaces is happening. But as the reports show, this is where the energy consumption will increase through because of cooling. So the project is open for participation, and I'm very happy that we have a colleague from India participating in this project. It's open for EU members and non-member countries. So we have a 3-year working phase ahead, so there's plenty of time to chip in and work on the projects. There are 2 easy possibilities as a limited sponsor, so there's no fee for funding, but no funding from the EU either. So, and that helps. Unlimited sponsors, you can also be part as authors of the deliverables, so publication is no problem. As an observer, this is even let's say more low-profile possibility to participate, but then you cannot be authors of the official publications. And how to contribute is pretty easy. You know, we have online meetings nowadays. It's not a big thing, so you can easily actively participate in research activities. And we have two meetings per year that are usually hybrid, which you can attend online, and they are usually in April and October. But this is, let's say, the minimum requirement to participate. This is the timeline. As I mentioned already, we have one meeting in Madrid in April. There's also a policy workshop on the day before. And the project closes in December 2029, so there's especially also for PhDs, there's a long time frame that you can contribute and work on this project. There's some further information on 2 websites. I just put the links here, so feel free to go there and also send me a message. Thank you.